so we're taking on homework set 27, most of which falls on pages 409 and 410. And this first problem that I want to do is problem 56. Interestingly enough, you really don't have a sister problem to this, but the technique required to do this work, I think, is general enough that I want to do one problem for you. I'm calling this graphing trig functions, and in parentheses with transformations, right? Because that's in order to graph this function that's given up here in problem 56. We're going to start with the basic graph of sine. We're going to do some stretching and compressing with this factor, and then we're going to lift the whole thing up with 3/2. So let's take a couple of steps in order to do that. So let's start by just graphing the sine of x, and you should be able to do this. You have to remember, it's very important to remember that the sine of 0 is 0, because that helps you distinguish in your mind sine from cosine, and that gets you very far down the road in being able to graph all the functions at once. You're going to see pretty soon that the sine and the cosine actually are exactly the same graph, if we haven't talked about this already. They're exactly the same graph, they're just shifted 90 degrees from one another. So again, it's very important to remember where one starts and where the other starts. In this case, sine of x starts at 0, 0. It runs up to 1, its maximum amplitude at pi over 2, goes back down to 0 at pi, down to -1 at 3 pi over 2, and back to 0. That's one period of the sine. So we're going to run up to 1, we're going to head back down to 0, we're going to run down to -1 and head back to 0. There you go, one period of the sine. So next, let's plot y is equal to sine of pi over 8 times x. So we've sort of replaced x with a number with a coefficient in front of x, and that number, pi over 8, is less than 1. And remember, what that does is stretch the graph, and we'll see that right now. We will still start right here at sine of 0 is equal to 0. That's a mantra you should continue to tell yourself. But look, you now have to go all the way out till 4 until the argument is pi over 8 times 4, pi over 2. And remember, at pi over 2, we go up to 1. So all the way out to 4, rather than pi over 2. Pi over 2 is a number like 1.57. Now I've stretched that maximum point all the way here out to 4. And likewise at 8, this is now sine of pi over 8 times 8, sine of pi. It's going to go back down to 0 here, and at 12 back to -1. So the stretched out version of the sine, I'm going to do that and swing back down here. So I can't even, I didn't even try to get in this case, the entire period of sine pi over 8. I guess I could come over here and draw the other side, but I think you see what's going on. So now let's take on the last two features at once. Okay, so I could have taken another step here and drawn this same function suppressed by 1/2. In fact, let me do that. Let me do that right here. Right? That means that every point on the curve just is reduced by a factor of 2. So I'm only going to get up to 1/2. I'm only going to go down to -1/2. 0 is 0, and so here we go. Back to 0. And back down. So this function is y is equal to 1/2 sine of pi over 8x. So we've done some stretching here, we've done some compressing there. What the feature of the 3/2 will lift things up. So the 0 line here is now lifted up to 3/2, and I'm going to draw this same thing with an amplitude of 1/2, meaning the highest point up here will be at 2. The lowest points will be down here at 3/2 -1/2, 2/2 are 1. All right, so if I just draw myself a little 1 right here and a little 2 right there, the graph is going to stay inside that bounds. Again, at 4, it's going to go up to its maximum. So there's its maximum right there. At 8, it's going to go back down to 0. At 12, it's going to go to its minimum, which is 1 in this case. At 16, back to 0. All right, so we've got a graph that looks like this. And there you have it. There's the graph of y equals 1/2 sine pi over 8x plus 3/2.